Previously, I had produced a little presentation about how to run Happy and Vue and your browser and so forth in both a development context and in a production context. And I've had more questions about that, and particularly now as we're doing development from off campus, I wanted to give you a little bit more of a picture of how to connect all the pieces and parts together to facilitate offsite development. And I'm going to focus here exclusively on the development configuration, and I want to take a little bit more detailed look at the way that the pieces and parts are deployed and how they're connected together over the network. So this first illustration here is just an example for a workstation, right? It might be your laptop or your desktop. This is the configuration that I use on my laptop when I'm doing development, kind of an all-in-one approach where all of the services are running on the same machine. So I've shown an IP address here that's just an arbitrary local IP address. But the pieces and parts are going to be, first of all, the Vue development server. That's the Vue CLI service that we've been invoking using a yarn target called UI watch. And that's the process that keeps an eye on your source files and generates updates to your browser to continually keep that consistent with what's in your source files. And it's by default runs at port 8080, and we can connect to it from our browser by just putting in the address bar localhost :8080. We also need to have access to our API. So this is the Happy process that we run using the yarn script called API watch. And by default, it listens on port 3000, and we can connect to it in one of two ways. The web browser can connect to it when you're running your application that was served over the web browser from the Vue CLI service, and you need to make a request to the RESTful API. Your browser code, which is usually implemented with Axios for us, is going to invoke an API endpoint on port 3000 of your local host, because that's where your API server is running. You can also test your API by using a client like Postman or Insomnia. And in both of those cases, if you wanted to talk to the API, you also want to connect to localhost :3000. And then the final piece here is the Postgres server, which most of you are not running locally. I run a local copy of it on my laptop. Many of you are accessing it over the Faraday server hosted in the department. And it runs a Postgres process that's listening on port 5432, which is the default port for Postgres. And that's connected to, from the API server, from Happy. It opens up a connection to the Postgres server so that when a request comes in on its port 3000, it knows how to route that request to the database. The next configuration is actually what most of you use when you're doing development here on campus. You're logged into some workstation, often a lab machine or your laptop or desktop, and you're running all the same pieces and parts that I just described for the fully local configuration, with the exception of Postgres. Most of you aren't running your own copy of Postgres. It's running on the Faraday server in the department network. So that Postgres process is now on a separate machine. It's still listening on port 5432. And now when you want to connect to it from your API server, you need to configure your database connection to refer to the Faraday server itself. As before, we're still running our Vue development server using the yarn target UI watch, and the API server running the Happy RESTful API using the yarn target API watch. Now what I'm really trying to get to here is to show you how you could do this from off campus. But I want to kind of take an intermediate step on the way there. So here's another configuration, same basic services that are running, but now on 3 different machines. On the back end, we still have the Postgres server running on the Faraday server inside the department network. But now instead of running everything else on your local workstation, I'm showing another configuration where we have a lab machine, so one of the CSE room number, sequence number machines that are in the labs. That's the machine that I'm showing running the 2 servers that we're connected to for development. So the Vue dev server still listening on port 8080, and the API server still listening on port 3000. You could certainly use this configuration in the lab while you're on campus, and say bring your laptop in and run your web browser and Postman, maybe if you're doing API debugging from your workstation, and just point those point that web browser at the Vue development server and at the API server. So instead of having configurations over here that would be like localhost :8080 to talk to the Vue development server, which works totally fine here when both of those processes are literally on your local host. If you're connecting across the network, you're going to want to use the network address for this Vue development server. If you look carefully at the output from Vue dev server, in other words, the yarn of UI watch, it actually gives you two URLs. One that has a host name of localhost, which is what you'd use in this configuration because you're connecting to a server running on your local host. The other is one that's a more general network address that will actually have the IP address of the particular lab machine in this case that you're running on. And that would be how you'd have to connect to that lab machine to access its Vue development server. If you're running in this configuration with your Vue dev server and your API server on a separate machine from your laptop, for example, and you try to connect to localhost, it's going to try to make a connection to a process running on your laptop. And there isn't that process that's running on your laptop. It's on a different server altogether. So you need to give the IP address of the server where that process is actually running and where it's listening by default on port 8080 or on port 3000. Now this just seems like a ton of extra work, but this is really just, again, a stepping stone to get us to where we want to go, which is to show a configuration that would work when you're off campus, when you're working from home remotely here at the end of the term. In this configuration, we still are going to want to use the internal resources available to us from, say, a lab machine and from the database server that's on campus. So on the assumption that you don't want to install all that stuff on your local machine but want to connect to it remotely over the network, this would be the basic configuration we want to use. The downside is this set of connections here that tie our local workstation that we're using at home to the machine on campus that we want to use to run our application is protected by the campus firewall. So these machines, like the lab machines and the database server, are all on the CSE network, which is behind a firewall. So you can't connect to them no matter how hard you try from remotely. So you need to kind of do two things. The first of those is to get set up with the virtual private network. And you can find out how to do that and get the details and how to download it and so forth from the CSE website. The second thing is, once you're connected to the virtual private network, you need to be able to make the connection from your workstation to the lab machine on which you're going to run these processes. And you're going to do that using SSH, the Secure Shell Protocol. So you're going to run a program variously called SSH. On Windows, one of the clients is called PuTTY. But you need something on your local workstation that's going to let you remotely log in over SSH to that lab machine. Once you've done that, you can then over on the lab machine, start up the Vue development server, the UI watch target, and the API server, the API watch target. The way that you're accessing that lab machine from your workstation is by connecting over SSH, which by default always runs on port 22. So there's a server on the lab machine that you're connecting to, and it's listening on port 22. The VPN for students is set up to allow access to that port from remotely. So you can log in once you've connected to the VPN, and you can start processes and run things on the lab machine just as if you were sitting locally at that machine. You've got a shell prompt, you can do anything you normally could do. The downside, though, is that because the campus firewall is quite tightly constrained, you are not going to have access to other ports other than port 22. So when you try to connect your web browser to port 8080 on the lab machine, it's not going to work. The firewall won't let you through. Similarly, when your web browser tries to make a request to the API on port 3000, it's also going to be blocked. So what we need to do is take advantage of a capability of SSH that's going to allow us to send the traffic for those ports through the SSH connection itself instead of trying to connect to those things directly. And that's what's illustrated here on the final slide in this presentation. So same basic setup, right? Here's our database server. We've got a lab machine that we're connecting to where we're going to run these processes. And what I'm showing here now is the SSH connection itself. So when we run our SSH client, the SSH program or the PuTTY program, normally all we are using that for is to connect to the SSH server process that's running on the lab machine, and what we get by default is a shell prompt that allows us to enter commands and do whatever we would normally want to do on that lab machine. In addition to that service, SSH can also do what's called port forwarding. So you can ask SSH to send traffic that is destined for a particular port on the remote machine through the SSH connection itself. So in addition to sending back and forth information from standard out and standard error and standard in like you use to connect to the shell, you can set up another channel that will tell SSH to tunnel traffic from your local machine to the remote machine over the SSH connection. Now that is, first of all, it's secure, right? Nobody can snoop on that, so that's a good thing. But also, it fits in with these constraints that are placed on our connectivity by Campus IT. We can just connect with that SSH connection on port 22, and using that same connection, we can also forward traffic to different ports on the remote side. So for example here, if we're looking at the web browser running on our local machine on our workstation, I'm assuming we've already made a connection using SSH to a lab workstation, and we've also told this SSH client we want to forward anything from port 8080 to the other side of the SSH connection. So I've kind of indicated that here by showing the SSH client that we're running on our workstation is now listening on port 8080. And when a web browser connects to that, it's going to recognize that it's forwarding that port. It's going to send the traffic through the SSH client over the SSH connection to the SSH server on the far side in such a way that the server says, hey, this is traffic that's destined for a different process here on the lab machine. In particular, we can configure it, for example, to send that traffic to port 8080 on the Vue development server that we're running over on the lab machine. We can do a similar thing with port 3000 so that the web browser's request for information from the API inside of our application or use of Postman or Insomnia, when we connect to port 3000 over here, we can configure the SSH client to say, hey, take that traffic that's destined for port 3000 here on the workstation, send it over the tunnel, and forward it on to a different process that in this case is also listening on port 3000. And the return values from both of these servers here is also going to be tunneled back across the connection and sent back to the original sender of the request. Now the way we configure that is we add some additional flags to SSH. So a normal SSH command, we just say SSH, and then we give the name of the server that we want to connect to. Again, this also has to happen within the confines of the virtual private network connection. Otherwise, we don't have direct access to this lab machine. But our normal mechanism would just be to say SSH and then the host name or the IP address of the machine we want to connect to without all this other DashL stuff in here. That would just open up on the remote machine, on the lab machine, a shell that we could then interact with back and forth from our SSH client running on our workstation. If we want to set up tunneling, we can add some additional arguments. So let's just talk about, I guess the arrows here I've got here for the API server connection. So DashL, which means local, I'm forwarding a local port to somewhere else, and it takes this kind of three-part argument. The first part is the port number that I want to listen on my local machine, right? So the 3000 here refers to this. I'm saying I want SSH to listen on port 3000, and when something connects to that port, it's going to forward the connection over the SSH connection. Now I also need to tell SSH where I want it to be forwarded on the remote side. And as you can see over here, I want to have it forwarded to port 3000 over here, which is where my API server is listening. And I want to keep it all within this local host. The SSH server is running here. I just want to go to port 3000 on that same host. So the second and third arguments are localhost, which actually is a host name from the perspective of this server process. I want it to go to the same machine that the server process is running on, and I want to send it to port 3000. Similarly, I've put in a -L flag to forward the connection to the Vue development server. So I'm saying on the workstation over here, listen on port 8080, and then send that connection across to the SSH server on the other side of this connection, this SSH to the lab workstation. And there, I want you to connect to port 8080 on that same host, right? The local host from the perspective of the SSH server. It's going to send that information onto this port 8080 and get a response from the View Development Server. And in both cases, the responses that come back from these servers is going to be sent back across the same tunnel to the client that initially made the request to that particular server. So that's kind of the simplest and most obvious, most memorable way of configuring port forwarding using SSH. But I just want to show you that there's a little bit more to it than just this kind of simple default approach. In particular, we're not constrained to these style arguments for the -L flag. The first argument there is telling the SSH client on our local workstation which port to listen on. And I've chosen to make it port 8080 on my workstation because it's a nice, convenient, and consistent way of referring to port 8080 on the remote machine. But I could make that anything. I could have this be 4040. And then I would say here -L 4040 localhost 8080. And what it would do is if anybody connected to port 4040 here, the SSH client would forward it to the other end of the connection on this workstation's networking stack and try to connect to port 8080 on that same host. So you can kind of renumber these ports if you choose to on either side. Of course, you need to make sure though that when you try to connect your web browser now that instead of going to localhost 8080, because we're now listening on port 4040, we want to go to localhost 4040. Let me also note that when we talk about localhost 8080 or 4040 over here, we're talking about the local workstation. When I say localhost anything, I'm saying connect to a process, connect to a port on this very machine. That's always what localhost means. So the local host that we're connecting to from in our web browser has no relation to the localhost argument here inside of the -L flag. That localhost is telling this end of the SSH connection to connect to its same server and to connect on port 8080 in this case. So keep those straight. When you say localhost, you always mean exactly the same machine. The other thing that we could do here is change the third component of these -L arguments. If I wanted to have my View Development Server listening on a different port for whatever reason, if I wanted that thing to be listening on port 6060, I could configure the View Development Server to listen on that port, and then I could change my -L flag to say 8080 localhost 6060. And that would take localhost 8080 connections that would be connecting to the SSH client here and forwarding that connection across to this server, which would try to go to localhost 6060, which would be the View Development Server over here. So these port numbers are completely unrelated to each other. It's common, again, to use the same port number so you don't kind of get mixed up, but there's nothing that requires you to do that. You can choose a port number pretty much however you like. And we could mix and match these things. I could have this thing listening on port 4040 and connect to port 6060 on the remote side, and that would also work, assuming that I change my browser address bar address to localhost 4040. Finally, the second argument in the -Ls tells this process which machine to connect to in order to access the port that's shown here as the third component of these arguments. Currently, we're using localhost, so it's saying whatever machine this SSH server is running on, connect to that same machine. But you can actually use an arbitrary IP address or host name to tell this SSH server what to connect to. We're limited as far as what we can connect to directly from our workstation because we only have access to that port 22. But if this machine is connected to a network with a bunch of other machines, we could instead request that this SSH server connects to one of those other machines instead of to localhost. So we could actually be SSHing into this lab machine and say run our View Development Server on a totally separate lab machine, and then tell the -L argument over here to request that other machine 8080, and that would essentially connect our web browser through the tunnel to the SSH server, which would then make a connection across the network to another workstation where the development server might be running, and then forward the traffic back to the original. So all three of the components of these -L flags can be altered independently. This tells us what we're going to be connecting to on our local workstation. This tells the server on the other side of the connection where to connect when it's doing port forwarding, and this tells it which port to connect to on that host name. The main argument here to the SSH command, which is what we've been using all along, even before you understood anything about DashLs, that's the machine at the other end of the SSH connection, the machine at the other end of this large black arrow here that I've labeled SSH tunnel. This machine, right, the one with that CSE address. So all of these flags are being evaluated with respect to that server. When we're talking about forwarding ports from port 8080, we're talking about forwarding it to the opposite end of the SSH connection, which is this server. When we're talking about where to connect to from that server here in the second and third arguments of the DashL, we're doing it with regard to that server on this machine, this lab machine. That's where the SSH server is running. That's what we're going to use to evaluate the host and port number that we're going to forward connections to. One final quick comment: when we're assigning port numbers to things, keep in mind that the port numbers below 1024, below the 1K boundary, are usually reserved by the operating system. So if I tried to start up my API server and have it listen on port 700, the operating system is going to have something to say about that. It's going to tell me I can't do that unless I have elevated permissions on that particular machine. So keep those port numbers, either leave them what they are here in the default configuration, but if you want to make changes to those to try this out or to reconfigure it for whatever other reason, make sure that you choose to listen on ports that are 1024 or above.